Are you ready to level up your future? Every Saturday, PDTV brings you maths class on PDTV YouTube channel, the place where knowledge meets opportunity.
High schoolers, level up your brain. PDTV maths sessions every Saturday. Algebra, fractions, equations, functions, all made simple, all made fun. So you all jump on the bus, let's go to where your future is bright. Master what we say, master what we need. No game, no gimmicks, just knowledge we are defend. PDTV maths every Saturday. High schoolers, level up your brain. PDTV maths sessions every Saturday. Algebra, fractions, equations, functions, all made simple, all made fun. So you all jump on the bus, let's go to where your future is bright. Master what we say, master what we need. No game, no gimmicks, just knowledge we are defend. What not draw TV, matter we love. PDTV maths every Saturday. PDTV maths, come learn the right
Yeah, hear me through Google Meet? Oh, thank you very much, Mr. Producer. And welcome back to another exciting PDTV session math class. And I hope you guys had a wonderful time last week as we touched on the first set of concepts that we were going to cover. All right. I just want us to take some time to kind of reflect back on what we looked at so that we can use that as prerequisite skills for what we need to move forward. All right. So I'm going to give you guys some time to actually log in, and then we can start with our discussion. So what we're going to be covering today is going to be just the continuation of what we looked on last week. All right. So welcome. All right. And guys, remember that you have to keep the mics muted. Have a discussion free class. All right. So I'm going to just give some other people some time to enter. And as I was actually saying, we're going to be continuing the concept of fraction. So we did a little bit of groundwork last week. So we're moving on to something a little bit more intermediate, but that's just how it has to go in order for you guys to learn in stages. All right, guys, remember the mics need to be muted. So I'm going to give us a couple of minutes to accept some more people. So, all right, welcome. Good.
High schoolers, level up your brain. PDTV maths sessions every Saturday. Algebra, fractions, equations, functions, all made simple, all made fun. So you all jump on the bus, let's go to where your future is bright. Matter what we say, matter what we need. No game, no gimmicks, just knowledge we are defend. What not draw TV, matter we love.
Let me go back here again. Give me 1 second, guys, please. 1 sec.
High schoolers, level up your brain. PDTV Maths. Sessions every Saturday. Algebra, fractions, equations, functions. All made simple. All made fun.
Alright, sorry about that, guys. So for the persons who are in the YouTube stream, they're having a little bit of issue. But I just want to know if things are okay where we are here in the Google Meet. So just kind of interact with me a little bit so the visual is okay. Okay, and so visual and audio is fine on my end. So probably it's on the YouTube end. All right, so let us. All right, let me switch back my thing now. Boom. All right, perfect. So in your own terms, guys, what do you think is the meaning of a multiple? What is a multiple in your own terms? Anybody, what is a multiple?
A multiple is a part of a fraction that is being multiplied.
All right, so this slide is now for, so right now, guys, we're doing a brainstorming. All right, BRA. All right, brainstorm. So right now we need everybody to chip in and give their version of the definition before we move on to the math concept. All right, so first person, what's a multiple? So a multiple
is a fraction being multiplied.
All right, so a fraction being multiplied. All right, anybody else? What's a multiple? So we need all these 4 arrows to be filled out, guys. Let's go.
A multiple is when you multiply a number by
All right, so we
whole number.
All right, so we multiply a number by a whole number. All right, we just use that for short. So we have 2 more to go, guys. We're getting them all filled right now. So 2 more persons who have not yet shared their answer. So what's a multiple? So we have 2 more sections to fill up. Let's go, multiple. Let's go. And you guys can use the first 2 responses as clues. This first person said multiple. All right, let's go.
Sir, someone in the chat said multiple is a number that can be multiplied by another number without leaving a remainder.
All right, that sounds good. All right, so multiple. All right, I'm gonna just do some shorthand version. So multiple is a number that can be multiplied by another number without leaving a remainder.
Yes, sir.
All right, so 4th one now. 4th and final one for this brainstorming. Let's go. What's a multiple? Let me look in the chat and see if any bright people is in the YouTube stream chat. Let's go, guys. For the 4th part, what's a multiple? Guys, these questions will set the tone for what we're going to be doing next. So we need to get this out. So 1, 2, 3, and 4. Let's go. What's
A multiple is probably a fraction that basically it is being multiplied.
All right, fraction. This kind of sound very similar to number 1 that you gave me first, right? So somebody else.
It is multiple a number by itself also.
All right. Okay. So let me take that. So multiply a number by itself. Boom. All right. So now, based on the 4 responses, guys, what is similar across all 4 responses? So if there is one thing that is similar across the 4 responses, what is similar?
Either the fraction being multiplied or the whole number.
All right. So you mentioned the word fraction. So fraction is a part of number 1. Is fraction a part of number 2? I'm just asking. So you say anything about fraction in number 2, 3, or 4?
No, because number 2 is talking about a whole number.
All right. So the person who spoke about fraction, she said fraction, and she also said the word multiply. So multiply, the concept of multiplication, that's in the first one. Can you see that in the second part as well? The second. Multiply by a whole number. All right. So it's also here. It's here. What about 3? Do we see anything about multiply? It's in 3?
Yes.
All right. So multiply. Yeah. Perfect. What about the number 4?
Yes.
Perfect. So guess what? So multiply. So all those 4 questions pointed us in the right direction. All right. So it's actually the concept of multiplication of a whole number. And the reason I give the brainstorming is that I want you guys to pull the answers out, because you guys know the answers, you know. You don't think you know that. Based on questioning, you guys will get to put them out. So let me. All right. So multiples. Matter of fact, I did a recap problem earlier. Guys, remember at the end of the last class, I gave us these 4 problems. How many person completed the 4 problems?
Me.
All right. So we're going to be doing a little bit of recap for the persons who are new. We're going to be touching on one of the multiplication and one of the division. Or if we move fast enough, we can do all 4. All right. So let's touch on number 1, where we are multiplying these 2 fractions. All right. Who wants to share? What would be the first step that you take in this multiplication? What would you check for?
The same denominator.
Go ahead.
The same denominator.
All right, I heard denominator. What about the denominator?
If it's the same.
You're sounding a little bit low volume. Could you speak up a little bit more, please? How do we multiply 3/4 and 2/5?
What I would do is I would multiply the denominators first. So what I know is 4 times 5 is 20, and then we can multiply the numerators by 3 times 2, and that would be 6.
Okay, so you're saying 20 and 6, right?
To get the answers. Yeah.
Okay. But is there anything that could have been cancelled before we do the multiplication?
Yes, the 20.
All right. So let's kind of clean this up a little bit. So on the fractions themselves, right? Is there
Yeah.
anything that we could have cancelled before we multiplied from left to right? Any cancellation? I know you guys see it, you know. We probably don't think you see, but I know you see it. Anything that we could have cancelled before we multiply?
We cancel the 2 and the 4.
The 5.
Right. I'm hearing 2 and 4. So how do we cancel the 2 and the 4?
2 in itself 1 time and 2 into 4.
All right. So 2 into instead of 1, 2 into 4 goes 2 times. All right. Is there anything else we can cancel or we can move forward now?
We can move forward.
All right, perfect. Guys, so always remember, whenever you're multiplying the fractions, we check to see if we can break the fractions down a little bit into their simplest form. All right, so that's what we just did for the 2 and the 4. So now we can multiply straight across. So, yeah, man, I know you guys know this. So what would be our fraction for the answer? The answer...
It would be.
Yep.
It would be
I hear the answer
6
coming.
20ths.
So if you multiply our top numbers, what do we get?
6.
Three.
Oh, wait, no. 3.
All right, so we got the 3 at the top, and our denominator.
Oh, it would
10.
be 3 over 10.
Yes,
3 over 10. Good. So always remember, guys, for the multiplication, check to see if anything can be cancelled. Then we multiply straight across. All right. So the reason for doing this, if we had multiplied first, we would get an answer where we would probably need to break down the fractional answer in its simplest form. So that's basically why we cannot do the simplification first. So let's say we didn't simplify, and we had just said 3 times 2, 6, and 4 times 5, 20. We could have broken that down a little bit more by using the 2. So 2 into 6 was 3 times, 2 into 20 was 10 times. So we cannot do the cancellation first so that our answer is in the simplest form. All right, so we're going to do one of the division. Let's touch on number 4, division. We're having the LCM type fractions coming up, but this is just the recap. Let's touch on number 4 problem. So we have 3 divided by 3 over 4. What could you do so that our fraction can look a bit more attractive? Because we've been working with fractions that have numerator, denominator, numerator, and denominator. But for this one, we're just seeing the number 3 divided by 3 over 4. What could you do to make this fraction look a little bit more appealing and easier to do?
3 over 1.
Perfect. 3 over 1. I know you guys are pretty smart. So just to stick a pin, guys, to kind of clear up some info. Whenever there's a number by itself, it doesn't matter what number it is. If it's even a letter for algebra, it doesn't matter. If it's standing by itself in terms of fraction, there is a 1 below. All right? There's a 1 below. So 2 is basically another way of writing 2 over 1. All right? I just want to get that out there. So you're saying we put a 1 below the 3. That's perfect. So now that part is out the way, what would be our first step in dividing these two fractions? Anybody?
Reciprocate the second fraction.
All right. So that went a bit quick. So what would we do?
The second fraction.
All right. So what about the first fraction, though? Let's do it in sequence. What about the first fraction?
Until I stay the same.
All right, so it stayed the same. So 3 over
You would multiply the 3/1 by the 3/4.
All right, so I heard something about multiplication. So let's get the sign aspect out the way for now. So whenever we're dividing, we keep the first fraction and we switch the division sign to multiplication like this. All right, so what happens to the second fraction?
We'd have to say 4/3.
Very good. We flip the second fraction, 4/3. Now we get in somewhere. So what would be, so we keep the first fraction the same, change the sign, flip the second fraction. What would now be our answer for this one?
Your answer would be 12/3, and then you would break it down, where the answer would be 4.
Excellent job. Very good, guys. That's very good teamwork. So one person stated the multiplication concept, another stated the flipping of the second fraction, and another one gave us the answer. That is excellent, guys. And that's what I want us to enforce whenever we are a part of the session. I know sometimes the guys are a little bit shy and all of that, but that's just how it is. Moving forward, you'll get a little bit more comfortable to share information so that everybody can benefit. And so that I can benefit as well, because probably I might make a mistake and I don't even realize that I make a mistake. And I'm also here to learn from you guys as well. All right. So the recap is over. That was the recap. And now we're going back to what we started out on. So multiples. So multiples are obtained by multiplying. Oh, so you see our word coming out now. Multiplying. That's why I kind of stressed the multiplication earlier. Multiplying a given number by integers. Now, what is an integer? Anybody? What is an integer? It's just a fancy word, but trust me, it's not scary. What is an integer?
Is probably a type of multiple.
All right, so a type of multiple, and a multiple, it's saying that a multiple is a number. So if it's a type of multiple, so it's a type of number. So an integer is a type of number. But can you give me an example of an integer? Sorry?
7 times 2.
All right. So 7 times 2. All right. So that's fine. But do you know that 7 and 2 belong to the group of integers? So integers are just negative and positive numbers. So we're gonna touch on some of that moving forward, but we're just kind of, chipping the ice a little bit for this session. So multiples are numbers obtained by multiplying a given number by integers. So multiply a number by a certain type of number. For example, the multiples of 3 would include 3, 6, 9, 12. So what did we, all right, let me see, 3, 6, 9, 12. What did we multiply 3 by to get 3, to get 6, to get 9, and to get 12?
1, 2, 3.
All right. Excellent. So by 1, by 2, by 3, and by 4. That's great. So let's look at the number 6. For this specific example, 2 and 3 are multiplied. So 6 would be a multiple of 2 and 3. And it might sound a little bit, but we're gonna clear that up as the examples progress. All right. Touch that already. Okay. So let's touch on the lowest common multiple. And this word common, right? This word common right here. All right, somebody can I'm hearing an echo. All right, so this word, all right, I might have to mute that person by myself. All right. Wait a second. I'm gonna let some other people in, guys. View, admit. All right, perfect. Let's go again. All right, back on track again. So this word common, it simply means that we're going to be looking on the LCM for more than one number. All right, so we're going to have to find something in common. So we're looking on this definition. So the lowest common multiple, or LCM, is the smallest positive integer that a multiple of 2 or more given numbers, of a multiple of 2 or more given numbers. So starting with these two set of numbers, line 1 and line 2. Our first number for line 1 is 2. Now all the numbers that follow after the 2, well, including 2, are actually multiples of 2. All right, so the multiples of 2 are all the numbers that you get whenever you multiply 2 by a certain number. So please remember that. So the multiples of 2 are the numbers that you get whenever you multiply 2 by a specific number. So what did you multiply 2 by to get the multiple of 4?
2.
You added 2.
2.
All right. So multiplication is a concept that is similar to repeated addition, if you notice. So, and it's great that you brought up addition, because multiplication is just repeated addition. So the two concepts are basically the same, but for the multiplication, so let's say we multiply here by 2. All right, it simply just means that we added 2. We added 2 to the 2. All right, and we added 2 here, added 2 here, 2, 2, and we go along. What did we times the 6 by to get the 2 by to get 6?
3.
All right, 3. So that's simple math. So we just continue moving across. 6, 7, 8, 9. All right, so we did that for line 1. So question, guys, what are the common multiples of line 1 and line 2? That's the question now. That's gonna push us forward.
6.
All right, so I'm gonna circle those. So the common multiples for line 1 and line 2, what was the first one?
6.
6.
All right, so we heard the 6. Perfect. What's common again?
12.
All right.
12.
All right, excellent. We heard 12.
18.
18. Lucky number 18. All right. So those are all the numbers that are common to line 1 and line 2. So next question now, to kind of tie in the definition and the topic. What would be the lowest common multiple for line 1 and line 2? Everybody 100% right there, sir. Perfect. See, everybody 100% mark. Excellent. So the LCM for line 1 and 2 would be 6, because that is the lowest number that is common to line 1 and line 2. So you guys, so as we go along, perfect. We did this. The common multiples, you guys gave me the answers. And what is the LCM? Perfect. Lovely. So you guys are doing extremely well. So we know how to identify common multiples and also how to identify the lowest common multiple. Excellent. So now this multiple concept brings us into addition of fractions. So last week we looked on adding and subtraction of fractions where we were not required to find any LCM, right? Why weren't we required to find LCM last week for the fractions? Why? Why we didn't find any LCM? Anybody? Anybody here?
Find the LCM by denominators.
All right. So the question is, why didn't we find any LCM for the addition that we did last class?
Because they have common denominator.
Thank you very much. Thank you. Yeah, very similar to what the previous person said. So very excellent. So when the denominators are the same, or it's a case where you can't switch it to a common denominator, we're going to move to the LCM. So guys, this is now one step higher than what we covered last class. I'm going to touch on the first example. So for this slide, we have addition, and for the other one, we have subtraction. So you guys getting the info right across the operations. So I know some of you guys know this, but as we look, things are moving up a bit higher and higher. So our numbers in question are 3 and 5. Let me ask you guys this. What is, matter of fact, let me write these out. So our number, so line 1, similar to what we just did earlier, line 1, and line 2. Let me drop that a little bit lower so you guys can see it. Give me a second, let me fix this. All right, we're gonna do it a little bit bigger. All right, so similarly to what we covered earlier, guys. So line 1, line 2. So now this is where you're gonna tell me the LCM for 3 and 5. So first, I want you guys to give me the multiples of 3 and 5 first. So we have, so 3 is here. So let me circle that. So 3 and 5, because those are the two denominators that we got. So what are, so give me the first 5 multiples of 3 and 5. First 5 multiples.
3, 6, 9, 12, 15.
All right.
3, 6, 9, 12.
3. Oh, that's a mistake. You see, guys, teachers make mistake as well. So that's a 6 should go there. So I don't want anybody to think that I'm the type of teacher who know everything. I don't know everything. I'm here to learn from you guys as well. 3, 6, 9, 12,
15.
15. All right, that's the first 5.
Yes.
Line 2. What are the first 5 multiples of number 5?
5.
All right, so 5.
10,
Excellent.
15,
20,
20,
Yep.
25, 30.
25. Oh,
30.
all right.
30,
So
35.
guess what? Me I go take that 30 today. That 30 today sound sincere. Me I go just take it. I want to put our answer on the board. We're doing the first 5, but I'm going to accept that for the 6th one. All right. So now that we have the multiples for 3 and 5, what is the lowest common multiple?
15.
15.
Oh, no, I get so bright. 15. Very good. 15. Because 15 is the lowest number that is included in the multiple of 3 and 5, or the lowest number that they have in common. Perfect. So now we get our 15. Now we draw our line right here. Get our 15. and they put it below. 15 below, guys. So what is the next step from here after the 15?
We have to find another lowest common denominator.
All right, that is very interesting. So you're saying we have to find another lowest common denominator. Why is that? I'm just asking, why is that though? Why is that? I'm just asking. I'm not saying it's incorrect or anything. I'm just asking, why do we need to find another lowest common denominator?
Because if we got the smallest common denominator for 15, that means it could work for the numerator.
Could work for the numerator. All right. So what would that number be if I was supposed to ask it to find it?
30.
All right. So 30. But what would you do with the 15? You would just dismiss the 15 or what?
I would turn the 15 into the fractions that it needs to be, like the mixed fraction.
Okay. All right. That's a very interesting point of view. And I think if we go that direction at some stages, we probably have to break that number down again. So it probably would have brought us back to the 15. But if we have the 15 as the more simplified version, then I think we can just go ahead and use the 15. All right, so that we want to make it as basic and as simple as possible so that I guys can get the foundation aspect of it. So once we get our LCM, 15, everybody did well on the LCM. That's nice. Once we get the LCM, this is what we do. So 15 divided by this first denominator. All right, so let me do the first example for you guys. So 15 divided by 3, that gives us what?
5.
5.
5.
Yeah.
All right.
5.
So that 5 will now multiply our 1 at the top.
Yeah. So.
All right. So make we just rewind that piece there again and come again. So remember, our 15. So we take our 15 from below, divide it by the first denominator right here, which is 3. So that's divided by 3 equals 5. So this 5, we're going to use it to multiply
Upper top part, upper the 1. So we need upper top part.
Yes.
So you go say 5 times 1. You put back.
Excellent. 5. So we see that, guys. So once we use I'm going to let you guys do the second denominator. So we divide the LCM by the denominator, and the number that we get, we multiply that number by the top number. And remember, keep our signs the same. So now we're at this piece, guys. So 15 divided by what?
5.
All right. 15 divided by 5, that gives us what?
3.
3. Very good. So what will we do with that 3?
You put it over the 2.
Put it beside the plus sign.
Yeah.
All right. Rewind and come again. Me like the vibes, I like the energy, I love it. That's nice. Yeah, man, that's some more way to interact. So we did the first piece, we got the 3. All right. So we got 1 at the front. For the first one, we got 3 into 15, 5. What did we do with that 5?
Multiply it by 1.
Thank you. Perfect. So now that we're on the second denominator, what would we do with the 3?
You times it by the 2.
What again?
Put it beside the plus.
But before we put it beside the plus, what are we going to do with the 3?
Multiply.
Multiply
Multiply
by
by the 3.
2.
The 2.
Yeah, 2.
Right now, when you're ready for school
Multiply by
challenge,
2.
when you're ready for school challenge quiz right now, they're telling them, I'm going to sign it
3,
now.
2, 6. You put back the 6.
3,
there.
2, 6. That's
Yeah.
good. I'm going to sign up for school challenge quiz right away with the maths part. All right. So quick recap now. The 15 below right here. We divided. So we're gonna each of these denominators, we have to divide them into 15 first. So into 15, we got the 5. 5 times 1, that's 5. So once you finish with that part, now we bring down our plus sign. 5 into 15, 3 times. We use that 3, multiply the number at the top. We got the 6. So now what is our final answer?
11.
10
Very good.
yeah.
Over 15. Perfect. Now I'm going to give us 30 seconds to ask 2 quick questions. Come on, guys. Let's go with the questions. Let's go. Anything that you're unclear about and you want a little bit of clarification? Anybody? Anybody? 15 seconds. And don't wait until the minute's finishing up. The seconds finishing up. Come on, we just call upon somebody. All right. Tell me one thing that you guys learned from this first example. One thing that you guys learned from this first example, guys. So if you were having a conversation with somebody after the class and you say, hey, Mr. Thompson just had his math class, and I'm gonna share one thing that I learned. What would that be? Anything at all?
I learned how to find the lowest common factor, multiple of the number, like for example 3, 6, 9, 12, 15.
Okay.
I say you're gonna find the lowest common. It would be 15.
All right. So what's the least amount? All right. So this is one set. That's one set. That's the second set. What's the least amount of sets do you need to have to find the LCM? Set of numbers. So we have 2 set of numbers right here. Let's say we got 1 set of number. Can we find a common multiple? If it's just 1 row of number, can we find a common multiple?
Yes.
How would we do that? So if it's just, let's say we're just looking on line 1 by itself. Now we have to pay attention to the word common. What does the word common mean?
Common means the less thing that is in line 1 and line 2.
All right, but remember, guys, I'm saying, what if we had only 1 line? What if we never had this line below? What if we only had line 1? Could we find a common multiple?
We will multiply the 5 with 3.
All right, just looking on the numbers. Could we find a number that is common to line 1 and something else?
Would that be 3?
Why 3? All right. Why 3? All right. So now that question is to just pull your thoughts out and hear how you think. So no. Why would it be 3? What is it common to?
12 and 15. Because 3 is a multiple of itself.
3 is a multiple of itself, but having only 1 set of number, is it common to another set of number?
Yes.
What's the other set of number? Remember, we just got 1 set of number, guys. Please pay attention. 1 set. So in this case, we would need to have a second set of numbers to see what is common to both set of numbers. All right. So I want you guys to go ahead and start working on number 2. All right. Start working on number 2. And then we share our answers. Giving the guys a couple of minutes or 2. You guys in like 3 minutes and we good. Anybody found the LCM?
Yes, sir. 8.
All right. It's all like we are work. All right, that's good. Now I'm gonna give you a couple more seconds now to finish up. Let's go, guys. The guys doing extremely well. I'm very proud of you guys. Let's go. All right. Anybody finish with the answer?
Yes, sir.
Perfect. So now I'm gonna let you guys prove to me now that you're learning something. So I'm not gonna say anything at all about this number 2. I'm gonna just let you explain it to me and tell me what your answers are, what you did to get your answer and to solve the problem. So I'm not gonna say much about number 2. So who wants to share their solution for number 2?
All right, sir. So
Me.
Right. I think I heard the boy vice versa. That boy and then the girl after, please.
so you would find the LCM between 4 and 8, which would have been 8.
All
And then
right. Nice. So LCM. Oh, let's do some annotation now. So the LCM for 4 and 8, what's that number? What's the LCM?
8.
All right. Did anybody get a different answer? Perfect. 8. So once you get to our 8, now what's our next step?
then you would divide the denominators by 8. So first you divide the 4 over 8, which will get 2. Then you
All
times
right.
2 by
So
the numerator.
all right, make a rewind a little bit now because I want us to get the math language right. So you said we're going to multiply the denominators by 8. We're going to divide the denominators by 8. Now remember, these are the denominators right here. So is it that we divide the denominators by 8 or we divide 8 by the denominators?
Divide 8 by the denominators.
All right, perfect. I know we're on the right track, but we have to just brush up and polish up as we move along. Excellent. So the full speed ahead now. Let's go. So we got the 8. So if we divide 8 by 4, what would be our answer here?
2.
So before we put that number right there, what do we need to do after we get the 2?
Multiply the 2 by the numerator.
Multiply the 2 by the numerator.
And what's the numerator?
3.
Excellent. Excellent. So that gave us our 6. All right, that's perfect. So now we're on the second denominator. You guys doing extremely well. Let's roll. Second denominator. So what's our result here?
1 times 5 would I put back the 5.
That one they sound anonymous. Where that one they come from?
Well, I'm there.
Well, that one they sound so. Where that one they come from?
Sir, after you divide 8 by 8, you get 1.
Perfect. Divide 8 by 8 to get 1. Excellent. All right. So, and that gave us our 5. And what's up with our 11? We're getting a lot of 11s over 8. 11 over 8. So what is this as a mixed fraction?
So 1 and 4 over 8.
1 and 3 over 8.
Is it 3 over 8 or 4 over 8?
4.
3.
Think about it. 3 over 8 or 4 over 3?
So 1 and 4 over 8.
3.
Yes, it's 3. Because if
8
it was
plus 3
4,
is 11.
if it was 4, it would have been a 12. You understand? Yeah, if it was 4, it would have been 12. All right. So, who wants to challenge number 3? I think the person who came up second, I'm gonna give them a chance to tell us.
Can I do it?
Yes,
sir?
please. Yep.
So what I got for number 3 was 2 and 1 6, because what I did with the denominators was that I made the fractions equal till the denominator was the same as the other denominator.
Okay, so you change the 3 to the 6.
Yeah, that's what I did. So I changed the 3 into the 6, and I changed the 2 into the 4, and then now I could add it. So one one 1 and 4 6 plus 3 6 equals 2 and 1 6.
All right. So what you just did, you brought us back through the common base procedure, which is fine. That's no issue. So I know that you guys have the common base method down to the T, but how would you approach this if you were to do the LCM procedure?
Sir, you would change the mixed number into an improper fraction and then find the LCM.
Okay, that sounds interesting. So 1 and 2 or 3 as a improper fraction would be what?
Sir, 5/3.
Okay, 5/3. So 3 times 1, 3 plus 2. So we multiply these, then we add those 2. All right, and then we have our 3/6. So for the person who was responding first, what would be our LCM for the 3 and the 6? The person who started at number 3. I think it was the female who started at number 3. What would be our LCM for 3 and 6?
6.
Excellent. 6. All right. So now what would be our next procedure from here?
You would add 5 plus 3.
All right. So 6 divided by 3, that gives us what?
2.
Right. So what do we do with that 2?
Multiply by 5.
By the numerator.
All right. And our answer is going to be what?
10.
Excellent. Yeah, man, I got book on for school challenge quiz next season. Second denominator now. 6 and 6.
1.
Right. So we got the 1 from the division. What are we going to use the 1 to do?
Multiply to the numerator.
All right. So what's going to be our answer?
3.
3. We're on the bright side. Very good. And now we final answer, we know so that part is the easy part. What's our final answer now?
13/6. Over 6.
All right. Who's going to switch it to the mixed fraction?
13 divided by 6 equals 2.
Equals 2.
The 2 will be the whole number. The numerator will be 1. And the denominator will be the 6.
Gosh, I'm not bright. So I'm going to line up some price soon. I can't make I solve my hard maths, man, and me na, you know, so we can organize that. I'm a bright man. So guess what now? We did 3 addition. So you guys get the gist of what is happening. So what I want you guys to do is to, if you can take a picture or write down number 4 and number 5. That's for your homework for the addition. So if you're on the phone, just take a screenshot. Also, if you're on the phone, use the phone, take the picture.
Yeah.
Right, number 4 and number 5, that's gonna be your homework for the addition. So we're gonna leave those 2, and we're gonna look on a little bit of multiplication, a little bit of subtraction. Sorry. So wherever the time brings us, then that's fine because we would have covered some addition and some subtraction. So number 1, you guys get moving on number 1. So start solving number 1. I need to hear the pages moving. I need to hear the brains ticking. And I need to hear some things going, guys. So number 1, 45 seconds on number 1. Let's go, guys. 45 seconds, number one. Anybody found their LCM as yet for number one?
Sir, 12.
12.
All right. That sounds good. All right. You guys are halfway. Keep going.
Sir, I got the answer, sir.
Oh, that sounds quick. All right. Guess what? We're going to give the rest of people like 15 more seconds or 20 more seconds to finish up. Everybody have to get some understanding. So we're going to give them some time to reflex the math cells in the brain. And I just want to commend you guys on the interaction. You guys are very, involved. You're giving the answers and not that shy. But for persons who are kind of sitting back, listening to other people just talking, feel free to ask a question. Feel free to give a comment, or feel free to be involved in the solution process, because the more questions I ask, the better it is for you to learn. All right? All right, so let's go for number one solution now. Who wants to give us number one solution? So,
7/12.
All right. Oh, that sounds quick, so. Very bright, so. All right, so I heard the 12 for the LCM earlier. Let me put the 12. So the answer for the problem is not really as important as the procedure for the problem. So all those procedures that you carried out, whether mentally or on paper, that is more important than the answer, because those procedures are like writing mathematical sentences. Like you would write a paragraph in English. All those steps that you followed are mathematical sentences, and those are going to help you to understand better. So we got the 12. So let's write our sentences now, guys. We got the 12. So what was our next step?
By 6. 12 divided by 6.
All right. So 12 divided by 6, and that gave us
2.
2.
What's the 2? So what do we do with the 2?
Multiply by numerator.
All right. So what's going to be our answer?
10.
Excellent. See it? You know, catch on right now. Full speed. Next one now. So we're at the 4. So talk me through the process, guys. So we're at the 4 now. What happens here?
12 divided by 4 equals 3.
Very good. You got the 3. So what happens with the 3 now?
Then you multiply the
3 times 1
Excellent.
equals 3.
Equals 3. And now we're at the final stage of this problem. And our answer is
7.
7 over 12.
7 over 12.
7 over 12. I'm going to ask you an interesting question now, guys. How do we change this to a mixed fraction? Very interesting question. How do we change it to a mixed fraction?
You can't.
Divide.
All right. So now we hear two answers. We hear divide. I hear somebody say we can't. Now, why do we divide? I'm asking. Person who said divide, why do we divide?
You can't get 7 out of 12 one time.
Go again?
To get it in the simplest term. You can get 7 out of 12 one time.
All right. So that question was a kind of a little bit a trick question. And the person who said 7 out of 12 one time, I heard you gave the correct answer before, but you kind of switch up your answer. And this is one thing I want you guys to know. You see, whenever you see an answer and you do, and you actually carry out the procedure in your head and you have your answer, don't be too quick to jump from your answer all the time, because sometimes you're correct. And that person said we can't, because this is a proper fraction. Smaller number is at the top, bigger number is below. So if we have the 12 at the top and the 7 below, now we could have divided 12 by 7, and then we do the rest. So once it's a proper fraction, we don't need to switch it unless we are actually making it more simple. So once the smaller number is at the top, we don't need to do any to commit any mathematics crime now and trying to change a proper fraction into a mixed fraction. Once small number is at the top, bigger number below, it's fine. All right. So guys, time is up on us a little bit. I'm gonna just let you work on this one. Work on number 2. I'm gonna take number 2. So you guys get to work on number 2, then we wrap up and I'll tell you what we're gonna be doing going forward. So let's go. Let me hear the sheets moving and the pencils rubbing against the page. So we're attacking number 2. Everybody, 1 minute. 1 minute for number 2. You guys are pretty smart. Very, very smart. So let's go for number 2. What's the first step that we do for number 2?
Switch the mixed numbers into
Change it to a fraction.
All right. Well, all right. So just one thing I want to point out, like whenever somebody is like responding, just allow them to finish and then you come with the result. So we change the mixed numbers to what?
Improper fraction.
All right, right. So that's basically similar to what the young man just said. So 2 1/3 as an improper fraction would be what?
7/3.
7/3.
7/3. Because 3 times 2, 6 plus 1, 7. You guys are firing and wiring on this one. So minus, what's this one as an improper fraction?
9/6.
9/6.
All right, 6 times 1, 6 plus 3, 9/6. Excellent. 9/6. Boom. So now I want somebody else to give me the LCM for 3 and 6.
6, sir.
6.
Well, right, someone. 6. Excellent. Because 6 is the lowest multiple that is common to 3 and 6. And just a little bit of recap for the multiples. If we have our 3 and we have our 6, these are the numbers we're looking at. Just a little bit of recap on multiples. What's the first multiple of 3? What's the first multiple of 3?
6, sir. 6. 6.
First multiple.
3, 6, 9, 12, 13.
First, right, guys, remember, we have to include the number as well, because if you multiply 3 by 1, the answer is 3. So let's go. So 3, 6, 9, 12,
15,
and so on. What about
15, 18, etc.
all right? What about
6, 12, 18.
I think the spotlight.
go again?
6, 12, 18.
Perfect. 6, 12,
12, 18,
18, 24.
24. 32.
32.
30,
Go again?
32. 30.
36 after 30.
Yeah, man. So now those are the first couple of multiples. Now, which one is common? Which one is common to both set of numbers?
12,
6.
6.
6,
All right, so this common, and this is common. So which one is the smallest one?
6.
Excellent. So guys, so that's how we get the LCM when we are doing this type of math. But after this, you guys will get so smart with this concept. You won't need to write it out like this. It will just come to your brain. All right, so quick and fast now, guys. I know you guys have this. So now let's do the division and the solution. What happens here? What goes here? So I have the 6 below.
6 divided by 3 is 14.
So 6 divided by 3 gives us what?
2.
And then?
You multiply it by the numerator.
14.
Okay, which should be?
2 times 7.
14.
14.
Excellent.
14.
I heard that 14 earlier, but I just wanted the guys to explain how that number came. Good. So 6 and 6 now, guys. You guys are doing extremely well.
1.
All right, so 6 divided by 6, 1. What happens to that 1?
1 times 9.
You multiply it to the numerator.
Excellent. That gave us our 9. Then what happens here?
14 minus 9.
And what's that number?
5.
5.
5.
Excellent.
5 over 6.
5 over 6. All right. So, numbers. Any question? 30 seconds of question before we wrap up. Take a screenshot of number 3, 4, and 5. You're gonna do those as homework. All right.
Can you go back to addition, please, Page?
Addition page. All right. No problem.
Sir, do you have
So I can take a picture?
Right. I'm on it.
Sir,
All right. So for the persons who are out there on the YouTube
Thank
stream,
you.
right? For the persons who are out there on the YouTube stream, we're basically wrapping things up now. And remember to be a part of the class next week, Saturday. The link for the class will be posted inside the stream chat, so you guys can access it from there, persons who are out there in the YouTube world. All right, so we're going to wrap up now, and thank you guys for tuning in. Remember, each and every Saturday at 1 p.m. to 2 p.m. PDTV math session, where we cover important concepts that in math that are giving the students a little bit of problems. So we break things down here, free for you guys, so that you can understand what is happening, and that math just need to be explained and taught well for you guys to get it. All right, so remember, guys, it's PDTV mathematics session every Saturday, 1 to 2 p.m. So thank you very much, and have a wonderful day. Thank you. No problem. Have a great day, guys.
Thank you, sir.
You're welcome.
Have a great day, too.
All righty. And guys, remember to follow me on Instagram, you know, guys. Listen. Instagram, I'm gonna write it. So Lincoln, so LINCOLN Maths. That's it. Lincoln Maths on Instagram. Just follow me. I'm gonna put some more stuff up for you guys. All right, so guys, have a wonderful Saturday, and I see you and hear from you again next class. All right.
Okay.
Bye-bye.
High schoolers,
Bye.
level up your brain. PDTV Maths sessions every Saturday. Algebra, fractions, equations, functions, all made simple, all made fun. So you all jump on the bus, let's go to where your future is bright. Matter what we say, matter what we need. No game, no gimmicks, just knowledge we are defend. What not draw TV.